In this unit, we're going to talk a lot about how to apply geometry concepts in the coordinate plane. And in this lesson, which is a really important lesson for this unit, we're going to talk about how to find distance in the coordinate plane. And it's really nice to use the Pythagorean theorem to find distance. So in that other last unit, we talked about how to find or use the Pythagorean theorem. Well, in this section, we're going to use it to help us find distance. And in that box at the top of your paper, kind of has the steps on how to do that. And essentially all we're doing is we're just going to plot the points that they gave us, and then sketch a right triangle, and do exactly what we did in the last unit. We label our A, our B, and our C. Okay. We will have to count to find the distance of A and B, and then we just plug those into the Pythagorean theorem and solve for C. And C is going to be the distance that we're trying to find. So it's not really much different than what we did in that last section, in that last unit. So we take a look at this first example. We want to find the distance of the segment AB graphed below. And we're going to round our answer to the nearest 10. So this one's really nice. The segment's already graphed for us. So we can go ahead and look at that box, skip step number 1, because it's already plotted and drawn. But we have to sketch our right triangle. And it doesn't really matter how you draw it. I'm going to draw mine to look like this. You just kind of connect those endpoints like so to make a right triangle. Some of you might be thinking, well, I made my right triangle like this. That's okay. It's still a right triangle. There's not really a wrong answer to what your right triangle is going to look like. Okay. Once you have your right triangle, you're going to label your A, your B, and your C. It's really, really nice. The slanted one, or the segment you're trying to find, will always be your C no matter what. So that slanted side is always your C. And then it doesn't matter which one you make your A and which one you make your B. Again, we're using the Pythagorean theorem, which is A squared plus B squared equals C squared. In this instance, all we have to do is just count to find our A and our B. And we're always searching for our C. The slanted side is the side we're trying to find, always when we're finding distance. So that's always going to say C. We're just going to count to find our A and our B. So here I'm going to count and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Bottom side is 12. Then I'm going to do the same thing to find our B. I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we counted to find our A and our B. And 4, we plugged them into the Pythagorean theorem, and now we can solve for C. To do that, you're going to do 12 squared, which is 144, plus 9 squared, which is 81, is equal to C squared. And then all you have to do is add those together. 144 plus 189 is 225. And then square root. The square root of 225 In this case, we didn't need to round our answer to the nearest 10th because 225 is a perfect square. But sometimes if it's not a perfect square, you just have to round your answer. So the length of AB is 15 units. You need to rewatch this example. If not, we're going to go ahead and move on to the next one. take a look at the next example. Take a look at number 2. We're going to find the distance between the following segments below, and then we're going to round our answer to the nearest 10. And these two look a little different because the points are not plotted for us. We have to plot them ourselves. So go ahead and plot those points. Negative 3, 1, right here, and 5, 7. Right here. And connect those points. Make sure you connect them and make a nice straight line. So there's our segment. Just like what we did in the last example, make your right triangle. First step. Label your sides. Your C is always the slanted side for the segment we're trying to find. And then it doesn't matter, that one can be your A and that one can be your B. And we're using Pythagorean theorem. And we're always trying to find C. Okay, so we just have to count to figure out what our A is here. So we're going to count. 1, 2, 3, 4, 5, 6, 7, 8. Do the same thing for your B. 1, 2, 3, 4, 5, 6. And then just solve for C. 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. And then to get C by itself, just square root. So our C squared 100 is 10. So the distance of that segment we plotted is 10 units. And you can either watch this example, rewind the video, pause if you need to finish writing things down. We're going to go ahead and move on to the next one. Same thing for B. Our points are not plotted for us, so we have to plot them ourselves. So we're going to plot negative 2, negative 5, which is right here, and then 8, 0, which is right here. And then connect. And then once you connect those lines, you make your right triangle. Cast to find your legs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Multiply the other leg. 1, 2, 3, 4, 5. And label as well. Again, we know our slanted sides are C. And then it doesn't matter which one you make your A and which one you make your B. And plug your values into the Pythagorean theorem. We got 10 for our A. We got 5 for our B. And the segment we're trying to find will always be our C. Go ahead and clean that up. 10 squared, 100. 5 squared is 25. And 100 plus 25 is 125. And then square root both sides. 125 is not a perfect square because when you plug in your calculator you get kind of a long ugly decimal. But if you round that decimal, you should round to 11.2. Yeah, the distance of that segment is about 11.2 units. You need to watch the video again. If not, go ahead and get started on practice.